So, is everyone ready to hear what's next? What's new at RAPID plus TCT? Let me hear a yeah or an oh yeah. Oh, you guys, you don't care about new stuff. So, I'm here to present what's new at RAPID plus TCT. Now, I wanted to explain the criteria that we're using. So, we are limiting the what's new to only those companies that are here on the show floor so that you have an opportunity to engage with them, see what they're talking about, see what they've announced, so you can further investigate. The other thing that we did is we limited it to those that wanted to help themselves. But what I mean by that is we requested information to be submitted to be considered for the What's New presentation, and the entire body of 48 companies that I'm going to present in 30 minutes is represented by those who submitted information. The other thing with this, it is a rapid pace discussion. My goal is not to educate you on everything about a company or a new process, but instead to give you a few nuggets for you to say, that's interesting, I need to go talk with them to learn more. Now, one thing we did in these requests for information is look to the Innovation Award, which I'm going to get to the finalist list in just a second. But to help you with a little bit of understanding, because it's going to move very fast, I've broken it into buckets. We're going to discuss hardware, then software, then 3D scanning, and in each one of those categories, I'm going to further break it down by ASTM classification, so you at least have some sense of what's the fundamental process or theory of the process, all with the goal of giving you pins that you can pop into your expo floor map to decide what your next day, 2 days, or 3 days look like on the show floor. Now, requesting information, we asked for submissions to be considered for the Innovation Award. These were reviewed, there were nearly 50 of them, reviewed by the additive manufacturing technical community to arrive at a short list of the finalists. Tomorrow they're going to go through the booths, talk with them, engage with them, and make their final decision, which will be announced from this stage Thursday morning just before the keynote speech. Now, our 8 finalists, congratulations to them, are Digital Alloys, E3D, Fabrasonic, Formaloy, NXT Factory, Rapidia, Sigma Labs, and Centratech. I am not going to describe what's new with each one of these at this time. I'm going to put them in the appropriate buckets. So with that, let's start with hardware, non-metals, and specifically material extrusion. The companies on this list are shown here. I'm going to discuss them one at a time. We're going to start with Dies Design. This is a little bit slow to react. There we go. What Dies has for you is new extruder technology, which may or may not be applicable to you unless your FFF platform, Fused Filament Fabrication Platform, is open to you modifying the hardware. So you may have to wait until they engage with and establish licensing agreements with others to get access to this, but I want to make you aware that it's out there. 2 new extruders, the Typhoon and the Pulsar. Typhoon is a filament-fed extruder running at roughly 12 cubic centimeters an hour, and the Pulsar is a pellet-fed extruder running at roughly 60 cubic centimeters an hour. Now, dumping material fast isn't the whole equation. It's dumping material fast and preserving quality. So it's got technology embedded to prevent oozing and dripping and threading that you could experience when you move that extruder at high rates of speed. E3D, same story as Die Design. You may not be able to access this or use this immediately unless you have access to the hardware of your FFF platform. What they've got for you is a tool changer. A tool changer that has multiple bays for multiple tools, kinematic coupling. They claim high positional accuracy of each tool that you're putting into service of 5 microns. And what this does is allow you to use multiple extruders, possibly from Dies Design, for different feed rates and multiple nozzle configurations, which allows you to do small features, large features, do the large features quickly, but also allows you to do multiple materials in a single build with an FFF system, and or attach other devices such as an inspection camera or a pick-and-place tool on your FFF platform. Then we have Big Rep. Been in the industry for a number of years. They have a brand new announcement. I believe they announced it 2 days ago. It's launching here at RAPID plus TCT called Studio G2. They also have the Pro and the Edge. These represent different levels of, pardon me, Big Rep, but product sophistication and also time frame on when it's going to be available. The Studio G2 is available now. This is a upgrade to the Studio platform. This is a meter class machine, or at least 1 meter by half a meter by half a meter. And what they're doing is re-engineering to drive out all those finicky points that affect reliability, speed, precision, the things that drive you nuts when you're trying to build a part through FFF technology, including an insulated chamber, including a thermally controlled and environmentally controlled filament cabinet, and including small items like ruby nozzles to prevent rapid replacement of your nozzles. That's the G2. Then we have the Pro. The Pro is in beta right now. You can't buy it immediately. It just went into beta. The Pro is the next step up. It's a full meter by a meter by a meter, but it is embedding new technology from Big Rep, all about speed, precision, and quality. Those two new technologies. The first is MXT, meter extrusion technology. What they've done is change the concept of how to extrude thermoplastic to give you speed and precision in the same configuration, and also give you quality, preventing drooling, as they say, or threading. MXT works by disconnecting the filament feed, which usually creates a back pressure, which is then heated and forced through the nozzle. It disconnects that. Feed filament in, create a molten solution, a melt pool, if you will, and then a positive displacement pump takes over and pulls the material to be extruded. It's also got feedback mechanisms and controls on that extruder head. Adding to that, they also imparted on the machine CNC controls for the motion control systems from Bosch Rexroth. These are closed loop controls. So the ability to make adjustments, fine tune the process as you're building to get the part quality out. The other item that they have is the Edge. This is still in development, planned to be in beta later this year. It is the Pro, a little bit smaller version with the MXT and the Rexroth controls, but it includes a thermally controlled build chamber to allow you to do high temperature thermoplastics. Not to be outdone, Ascentium, a materials company, has been here at RAPID plus TCT for a number of years. Wowed us with something called Flash Cure a few years ago. Now they have a platform, a hardware platform, HSE 180S. Stands for high speed extrusion. They're targeting 10 times the throughput of a competitive product. They are approaching this similar concepts, but different interpretation. Their extruder is high torque. High torque, no slip. It also heats and senses at the extruder nozzle to understand what that material is doing. They're using direct drive motion systems. Oh, by the way, the extruder also goes up to 500 degrees C in just 3 seconds. The extruder head can move at 3G acceleration. And they also have rapid heating and control of that build chamber with multimodal heating using different heat sources or different heat methods. We also have Robos. Once again, fused filament fabrication. The 1+400 Extreme. 1+400 has been previously launched. The Extreme is what the new version is. And this is going back to, not necessarily the drawing board, but going back to drive out those little finicky things that affect accuracy of your parts and repeatability of the process. Their direct drive concept is beltless. They're also using their own extruder technology and imparting closed loop control. So once again, the system itself can monitor what's going on and make adjustments. Then we have RISE. This is a modified FFF process. They call it augmented deposition. You may be familiar with it. They've been out for a number of years. They extrude thermoplastic and then come in with a jetting operation to deposit a material that changes the characteristics of the thermoplastic that has been deposited. Previously, that was to make for very easily released support structures. They announced the X-Rise. X-Rise, the jetting operation adds C, M, Y, and K, which are the primary colors for printing operations, allowing you to do fused filament fabrication, augmented deposition in their terminology, with full color. They pair that with the one-touch software, which allows you to take a monochrome part, add text, add graphics, or add texture to that model, which then can be pumped through the X-Rise system. Oops, I didn't have it on RISE. And then finally, MakerBot with the method. I found this one interesting. MakerBot grew out of the RepRap open source program. With method, they are distancing themselves from RepRap, stating that they are bringing you a higher quality product because they're borrowing from their parent company, Stratasys, the technology that drives industrial solutions. A heated build chamber with recirculation, an environmental cabinet for the filament to keep it nice and dry, and other features, $7,000. Now I'm going to go to vat photopolymerization with Stratasys starting off. Here's our list of vat photopolymerization. Stratasys starting off, but I want to connect the dots here a little bit to show that you need to investigate. Stratasys introduced the F120, which is a fused filament fabrication material extrusion system, for $12,000. What do you get between a $7,000 MakerBot and a $12,000 F120? I don't have the answer to that, but that's the kind of information you need to dig out when you're making a buying decision. But the big news from Stratasys, they're in vat photopolymerization. Big break from the technologies that they've become known for. They are now into stereolithography. Month and a half ago, they announced the V650 Flex stereolithography machine, going after maintainability and reliability of the machine. Big envelope, 20 by 23 inches, yet a small footprint of about 4 foot wide. It's also another big break for Stratasys because it is an open material platform. You can buy whatever photopolymer you choose and put it on this machine, but they do note that they have the process tuned with 4 DSM resins. Next up is CSMA. This is a company I think of for metal additive manufacturing and traditional manufacturing tools with a focus on finer, smaller parts and sometimes precious metals, such as jewelry applications. But they've stepped into the polymer world of additive manufacturing with 2 products called Everez, Everez Zero and Everez Uno. They're looking at automating the DLP process by driving out some of the touch points. That automation includes automatic detection of the material that you fed into the machine, automatic bed leveling, and then another factor is bed tilting. To release the adhesion of part when you're doing bottom-up illumination, release the adhesion of part to that interface surface so that you don't damage the part and so that you can run faster. Not to be outdone, Nexa 3D has announced the NXE 400. It is a photopolymerization technology. It is not DLP based. They're combining several unique things. First off, they're using essentially a matrix of light, controlling that light to give it direction. Then they're passing that through a mask to further refine the illumination on the photopolymer. And they use a technology, their own technology called LSPC for lubricant sublayer photocuring. That is basically a wettable membrane that lubricates to allow release, but also promote resin to flow in under the surface of the part when you move to your next layer. NXE 400 comes in 2 varieties, a 7-liter capacity and a 16-liter capacity. What the company is stating is 2.5 times the capacity, 6 times the speed of their nearest competitive products. Then we have Formlabs. Formlabs announced the Form 3 and Form 3L with a new name, a new process that they're calling low-force stereolithography. Instead of tilting the bed or having a wettable membrane for release, they are actually using a deformable interface that allows the part to separate from the part. They call it low-force stereolithography because something really important to consider that many people don't is the force of that suction as you're trying to draw the plate or tray or membrane away from the part can damage the part or force you to use stronger supports, more supports. So with low force, their claim is that you can minimize your support structure and do finer details without concern for the quality of the part. The Form 3 is roughly a 6-inch by 6-inch platform. The Form 3L is 13 by 8, L for large. They've also designed 2 new light processing units, which give the ability to have the laser beam, this is a laser-based technology, always perpendicular to the surface that it's drawing instead of using a centralized scanning system, which gives you that rotational axis. Carbon, as we just heard, introduced the L1, L for large, big enough to make the helmet liner components. And you also heard quick reference to the M2D. D stands for dental. This is the M2 platform, which has been out for industrial use, sized appropriately for dental aligners. They're also packaging that with software. other tools to help the dental labs more easily adapt and incorporate additive manufacturing into their workflows. And then finally, Origin. I suspect this booth will be busy if they do what I've been told they're going to do, which is to step out of stealth mode. Origin has been a source of conjecture because they're not describing what they're doing. The platform is called the Open Additive Production Platform. The process is called P3 for short, or Programmable Photopolymerization. We don't know anything else other than the promise that it unlocks the potential for new chemistries and new sets of material properties out of a photopolymerization system. You're going to have to stop by the booth to learn more because I don't know anything else. We then have hardware in the non-metals. Powder bed fusion with NXT Factory, QLS 350, quantum laser scanning. They are also using a matrix of energy to expose a full layer at a time, increasing speed. Their claim is 4 times that of competitive laser sintering systems. They also have a real cool factor, an autonomous material chamber that docks with the machine, and then when the build's done, it autonomously throttles off to the next stage of the process. We then have Sintertech with the Sintertech S2. This is a smaller laser sintering platform, about 160 millimeter diameter build area, but what they're doing is giving you a complete solution from end to end that allows you to buy when you need or what you need. So the laser sintering, the material core unit, then they have a material handling unit, option for blasting, option for polishing, and option called Vortex for further material handling. Then we get into EOS, the Integra P400. I find this interesting because EOS, German company, German engineering, actually released control of the design of this machine to their North American associates. This is designed for speed, redesigned for speed, redesigned for reliability, redesigned for serviceability. A lot of new features in it, including new recoders, something called skywriting, and hotter lasers, 120 watts on the CO2 laser. Farsoon is attacking the speed problem, and not problem, speed issue, and quality concerns by getting rid of the CO2 laser, replacing it with a fiber laser. They call the technology FLIGHT, for fiber light technology. This is all about energy density, getting the energy where you want it, when you want it, how you want it, and also smaller spot size. And finally, HP recently announced in its lineup the Jet Fusion 5200. This is a follow-on to the 4200 series, and this is to address those that have demands for higher production capability than what the 4200 series is capable of doing. They do that by increasing throughput by 40% and decreasing operating costs by 30%. The details on how they achieve that, you will have to get from them at their booth. We then go into hardware, metals, binder jetting, just one company listed because it has to be new. They have to be here on the show floor. This is X1. You will be the first to see the X1 25 Pro. This is a binder jetting solution using MIM-grade powders, which is important because the supply chain exists, the knowledge base exists on how these materials behave, and also it's much less costly than the materials used in powder bed fusion for metals. It does that by creating a fluidized bed to overcome the issue of fine particles, creating a raking effect when you're recoating. They're not the only ones doing this, though. Desktop Metal is out there doing the binder jetting process. Digital Metal, I forgot one, and HP also announced. Thank you very much. HP also announced their version. Then we move to directed energy deposition. So fundamentally, directing energy at a spot, then introducing your material into that energy beam, stream, or flow. Here we have 3 companies for your perusal. Formaloy with the alloy development feeder. They've got a line of DED, or laser metal deposition systems, but they've added this development feeder. The premise here is to develop a new alloy. Gets a little bit costly, a little bit of an issue when you're using a commercial system with the normal hoppers, because those hoppers require ½ liter to 3 liters of material just to fire up the machine. The alloy development feeder is 16 vials, each one holding less than 50 milliliters of material for easy, rapid material development processes. Then we have Optimec. The long-time player, been around for about 25 years with LMD processes. They actually call theirs Lens. They came out with the 860 Hybrid CA. The name, if you can interpret it, says it all. Hybrid, it is a hybrid platform, so additive and subtractive processes combined into one platform. 5-axis motion on that platform. The CA is what makes them able to say, we are the first. CA stands for controlled atmosphere. So now for the first time, you have a hybrid platform, controlled atmosphere, allowing you to process reactive materials. Then we step outside into a different concept of DED, SPE3D, who announced the light speed last year here at RAPID, is now showing or talking about warp speed. This is a cold spray technology, so firing metal particles at supersonic speeds at a substrate. When all that kinetic energy is transferred into the material, it bonds. What they're talking about, what they're going to be able to show based on warp speed, is a copper rocket nozzle weighing 44 kilos, measuring 10 inches in diameter by 12 inches tall, that they were able to produce in just 8 hours. The warp speed machine will not be here, but they'll be happy to discuss it with you. I believe that's probably because of logistics. That is an Australian company. It takes a lot to get a big machine here to North America. In powder bed fusion, 3 companies to talk about. Aurora Labs, this is someone to take another look at. They were born out of a Kickstarter program, and the machines early on looked like they came out of a Kickstarter program, and they were attacking purely the cost basis. Now they have options in beta, RMP1, which they're attacking speed, they're attacking satisfying the mining industry of Australia, adhering to their standards, adhering to the characteristics that they need through the machine and the ecosystem that goes around it, looking at a faster process. No comparative data, so I can't tell you how fast is fast. About a 17-inch diameter build area, so it is a reasonably sized machine. MCP, however, is something you're going to want to talk to them about. It's in development. Multi-layer continuous printing is what it stands for. What they're doing is driving out all the lost time, non-value added time, not all of it, most of it, for recoding the metal powder by using a series of troughs that have varying amounts of material in them. As that scans across the bed, troughs are depositing material at different rates, and one trough will be at the proper layer thickness while the laser is drawing within that trough. When the next trough hits the proper layer thickness, it's drawing in that. Right now, they're able to do 55 times the speed, their claim, versus a comparable machine from any competitor, doing 30 layers in one pass. Then we move into evolutionary changes. Not everything on this list is revolutionary, but it doesn't need to be. People and companies are taking the steps we need to make these systems better for our applications and better satisfying our needs. Additive Industries has DMLA. This is about laser assignment, dynamic multi-laser assignment. If you're working with multiple lasers in a powder bed fusion system with metals, you got a little bit of a problem. They generate condensate, also known as smoke. They generate splatter. And if you have 2 lasers working, that smoke is now an impedance to the other laser, diffracting some of the energy, absorbing some of the energy, creating an energy at the focal point less than what you desired. So what they're doing is programmatically assigning laser paths to avoid this degradation of part quality by avoiding passing the laser through the condensate or into the splatter. And SLM Solutions, an upgrade to their SLM 280 called the Production Series. This is about being faster, satisfying your needs for throughput in a production context, but also taking out some of the little nitpicky things that get in the way of production, such as adding a permanent filter and optimizing the gas flow. Now, this machine is here on the show floor, but it will not be in operation because they want to invite you to peek under the hood to see what's going into this to make it a Production Series system. We then go to material extrusion for metals. Rapidia, extruding a combination of binding agent and metal powder, which is being done by others, but their binding agent is an aqueous-based solution. That allows it to evaporate during the 3D printing process, which means that they can skip the debind step that everyone else has to go through when you got a combination of binder and metal powder. That debind step takes hours, many hours, and also introduces a possible source of problems. If you don't fully debind, you can have outgassing and other issues that affect part quality. And then digital alloys. I think this belongs in material extrusion. I don't quite know. The process is called joule printing. It's based on joule heating, which is also known as ohmic heating or resistance heating. Filament or wire-fed additive manufacturing metals machine, where they are taking that wire to a full melt through resistance heating, and what comes out of the nozzle, if you will, I don't know if that's the proper terminology, is a full melt alloy, and they are going after speed. What they're hitting are 5 to 10 kilograms per hour. Isotropic properties, 99.5% density. Finally, hardware for metals. We have Just One Sheet Lamination. This is a company that's also been around for a number of years. You probably don't know the name because they've predominantly offered services or custom-made machines. It uses ultrasonic welding. They call the process ultrasonic additive manufacturing. For the first time in their history, they now have a product that you can look at the specs on and buy off the shelf, if you will, called the Sonic Laser 1200. We then move into software, breaking this down to pre-process and process. For pre-process, and this is exciting because software finally is stepping up to take some of the burden off of us and the amount of information we have to retain to execute on additive manufacturing. Paramatters introduced CogniCAD 2.1. This is a generative design, topology optimization, lightweighting program, and what their claim to fame is fully automated. What they mean by that is once they're done creating your geometry, it's ready to print. No additional massaging is needed, and it is watertight. Thing I like about this is these guys use a lot of different loading conditions: force, momentum, thermal, vibration, acceleration, and on and on and on to optimize a part for the performance needs that you have. Link3D announced shape nesting. I wouldn't say this is rock your world, but keep in mind, Link3D is a software company providing the tools to help you control and exercise additive manufacturing, and this is just one of the latest tools. This is for nesting parts in 2D for processes like FDM, or 3D for processes like the powder bed fusion that we just discussed. Dendrite came out of stealth mode a month and a half ago. Additive Toolkit. You will be able to decide if this is worthy of your attention in about 1.5 minutes because that's how fast the demonstration goes. They take native CAD data, they orient, they add supports, they can do lightweighting if you choose, and they define the build parameters. They accelerate the process by relying on the graphic processing unit on board in your computer and using its horsepower. It's also an open platform in that they use Python as a coding, for coding, and they provide Python APKs so you can hook in and you can customize to your workflow needs. Teton Simulation, you will see them in the program as Teton Composites, but intelligent slicing automation. Here they're looking at machine learning, hands-on experience to drive out the need for tribal knowledge to prepare your parts to 3D print them. So Intelligent, this is an alpha, it's not fully released yet. Intelligent is using what the software knows to apply the slicing and build parameters to get out the part quality that you're looking for. CG Tech, producer of the Vericut software, which is in the CAM world, has stepped into the additive world with the controls for your additive programs, and it seemed to be heavily focused on hybrid platforms where we combine additive and subtractive, allowing you to define the tool paths and that working concert between the two different mechanisms so you avoid collisions and crashes of the tool, and also has intelligence understanding the activity of the laser, the gas flows, material flows. So it's not a dumb solution, it understands what you're programming for. In pre-process, we also have Velo 3D, mention them quickly. This is a hardware manufacturer for metal additive manufacturing. Their claim to fame is supportless powder bed fusion, metal additive manufacturing. Part of what makes that work is that what they announced end of last year, software called Flow. It's taking all the intelligence of what goes on in that process to compensate the model to avoid deformations and also avoid the need for support. So it's a simulation tool. Likewise, AlphaStar is a simulation tool. Simulate to print is what they're calling it, called Genoa 3DP. This is allowing you to simulate material characterization, build optimization, and out to in-service loading conditions of the part. Simulate so that you allow the software to do the heavy lifting. And finally, Siemens PLM also has a simulation tool recently announced. In their case, they're the NX guys, simulate and then automatic compensation of your CAD model to compensate for the deficiencies that result from the process of additive manufacturing. In the process category, 3DQ with QPOD and QSuite. QPOD is a collection of 9 FFF systems. A little bit of automation put on that hardware for automatic part unloading and loading, but driven by the QSuite software. For you set up the queue, it does all the scheduling of the machines to build your queue of additive manufacturing parts. QSuite is planned to be available as a separate product later, at a later date, unannounced. So it could possibly be available to you to control your production workflow. 3 Degrees announced Trace. This is all about traceability. 3 Degrees' focus is on traceability of part information through the entire workflow. So you can confirm that safety is built in. You can confirm compliance. What they're looking to do or have done is create a streamlined, simple process to collect all of this data in this wild and woolly world of additive manufacturing. Value chain is also about traceability. Regrettably, their module is also called Trace, but it's part of a program they call DNA AM. However, unlike 3 Degrees, their focus is on material traceability, consumable traceability, and build plate traceability. Documenting that information for eternity so you know what went into the parts in case, God forbid, there is a failure. Sigma Labs announced PrintRite 5.0. This is melt pool, real-time melt pool analytics, not monitoring, analytics, and automatic anomaly detection to allow a feedback loop, closed feedback, to adjust the process parameters to make a good part. Also provide the documentation. They are saying it is comparable to and compatible with NDT, non-destructive testing, through CT scanning. 3 Your Mind moved out of beta with the Agile MES, Manufacturing Execution System. This is about a queue of parts with smart part prioritization, dynamic scheduling, and monitoring to allow the software to help you control that stable of additive manufacturing equipment that you have working on your behalf. And Blue Streak is also about MES, Manufacturing Execution Systems. This company I feel bad for. They've had a lot of success with some big name companies with a lot of additive manufacturing equipment. However, they can't talk about them under NDA on this. But this is a manufacturing execution system built from the ground up for additive. Unlike 3 Your Mind, they also have plans to roll in other business functions such as ERP, accounting, and CRM to have a total package, more mimicking an SAP or an Oracle instead of a standalone element. In post-processing, we have 2 companies, Post-Processing Technologies and AMT. Post-Processing Technologies announced the 40, little brother of the Demi. This is for support removal of FDM and photopolymer processes like CLIP, SLA, and PolyJet, and also resin removal on those photopolymer processes. AMT, a bit in stealth here in North America. In Europe is really where they established themselves first. Process is called BLAST. It's for thermoplastics, and it's about surface smoothing and making those surfaces watertight. Post-Pro Mini is a smaller version of the existing system they have. The one of most interest to me was Post-Pro Color, which does the surface smoothing, water tightness, and imparts color on your additive manufacturing part. Forgetting my pushes here. And finally, we'll wrap it up. They're screaming at me on time here, but I don't want to short you. 3D scanning, 3 companies I mentioned. Creaform with the HandyScan Black, re-engineered handheld scanner, moving it towards a metrology solution instead of an engineering data capture solution. 4 times the resolution, 3 times the speed, giving you the accuracy, the quality of the data collection. We then have Artec, which has the Leo. It's been announced some time ago, but it's now available. It's commercial launch now. This is a handheld scanner, untethered to any computer device, so working in free space. It measures 9 degrees of freedom, so it knows exactly where it is in space, and it does onboard processing of the scan data So what you have on that scanner, once you download it to computer, is ready to rock and roll. The Micro is a desktop scanner meant to be their entry into the metrology world, claiming 10-micron accuracy, rotating turntable, tilting turntable, 2 cameras to get color and data measurements. And then finally, Innometric, with the release of Polyworks 2019 Collaborative Suite. This really caught my eye. Their premise is metrology data is often locked up to the metrology experts, other than a static report that says go, no go, pass, fail. They want to make the data available and more dynamic across your organization. One of those tools is called Data Loop. It provides a dashboard of the metrology or inspection information to anyone that needs to see it in a summary format, and allows you to drill down to find the information supporting what's really going on in that measurement of that part. Fast-paced, I know, I apologize, but I wanted to give you a taste of things to allow you to plan your time on the show floor. The show opens tomorrow at 10 o'clock. I hope I've given you at least a few tidbits that you can use in identifying your path through the show floor. And as you journey through the additive manufacturing landscape here at RAPID TCT, I wish you a lot of luck, and I hope you have a lot of fun discovering new solutions. Thank you very much.